Welcome to this puzzle session. Here is the problem. 17 rooks are placed on an 8x8 chessboard. So a rook is a piece on the chessboard which sort of looks like that, and it moves vertically or horizontally. You can Google and see the details. We want to show that there must exist 3 rooks out of these 17. There must exist 3 which do not threaten each other. So a rook threatens the things which are on its row and its column. So we want to show that no matter how you place 17 rooks on an 8x8 chessboard, you can always find 3 of them which do not threaten each other. So for instance, you should be able to find something of this sort, some 3 rooks placed like this, because this one threatens the things here, and this one threatens the things here, and that one threatens the things there, and these 3 do not threaten. None of these 3 threatens any other of these 3. So that's what we want to prove, and it's a very interesting puzzle. As usual, you're encouraged to pause the video and find your own proof or solution before we look at what I'm going to discuss. And with that, let us now proceed. So there are multiple ways of doing it. There is one very pedestrian way of doing it, which is how I did it, but that probably is not even amenable to generalization. The solution that I'm going to discuss is a particularly elegant one, and it goes by coloring the chessboard in a certain clever way, which just immediately makes it clear as to why such triplet of rooks must exist. So this is our chessboard, and how are we going to color it? We will color the main diagonal in one color, and then we'll color the diagonal above it in one color, but then there are only 7 squares here, and we want to go up, but there's nothing up, so we'll come down and color this guy also with that same color. Right? So this may not be clear yet, but I will make it clear in no time. Similarly, we will color this particular diagonal. There is nothing above, so we will come down and color these 2 things. So we are coloring diagonally, and to make it very, very clear, the way we are coloring is this. So the main diagonal is colored using one color, red in this case. Then the diagonal above it is colored blue, and we come down and kind of complete that diagonal. Then the thing above is colored green, then we come down and kind of complete that. Similarly, then we have this pink one, which is completed by doing this part also, and so on and so on. So there are total number of 8 colors that we used, and this entire chessboard has been kind of partitioned into 8 parts, right? And that partition is clear by the coloring. So how does this help? Well, there are 8 different colors and 17 rooks. Every rook is sitting on a unique color. Of course, 2 different rooks can be sitting on the same color. What I mean is, one rook does not occupy 2 different colors, obviously, because one rook is sitting on one square. So every rook has a color. So you can say there are 8 cages or colors and 17 pigeons or rooks. 17 rooks have been placed in 8 colors. So by common sense or by the pigeonhole principle, some 3 of the rooks must share a color. Right? There must be a color which is hosting at least 3 rooks, because 17 is 8 into 2 plus 1. Right? So whichever color that might be, suppose that color is green. So suppose there are 3 rooks sitting on the green color. By the way the coloring has been done, since we are coloring diagonally, it is impossible that 2 of these rooks share a row or a column. That is the reason why diagonal coloring was chosen. Okay, so that's the solution, that's all. Once you color diagonally and apply the pigeonhole principle, you immediately see why 3 such rooks exist. Okay, so that's very nice. As usual, like, comment, share, subscribe, and I will see you next time.